Hello everyone, welcome to day 7 part 2 of our Linux beginner to pro series. Today we'll be learning about logical value manager. In the previous class we learned about standard partitioning where we saw that standard partitions cannot be extended or reduced. Once the file system is created with the standard partition, it has a fixed size. If you want to have more space on the same file system, that will not be possible. You will have to create a new partition and then you'll have to copy the data from the previous partition to the new bigger size of partition so that you can have more space. In Logical Volume Manager, we have the feasibility to extend the file system and also to reduce the file system with some file system types. Logical Volume Manager is made up with three components primarily. One is physical volume, then volume group, and the logical volume. Physical volumes can be made with either a partition or you can use the whole disk also. In the standard partitioning, your standard partition can be created out of a disk, so its size will be maximum to the size of the disk. But in the logical volume manager, you can combine one or more physical volumes into the volume group and then you can create larger size of logical volume even though if you don't have any of the physical volume of that size. For example, if you want to create a 24 GB of logical volume or file system, you can have a 10 GB of disk and you can have a 15 GB of disk, and you can combine both of them together. They make 25 GB of volume group. Now you can create 24 GB of logical volume out of it. There will be no problem. But in standard partitioning, this is not possible. You can create either 10 GB of partition or 15 GB of partition out of both the disks in this example. The name volume group doesn't come from the grouping of logical volumes, but it actually comes from the name of group of physical volumes. So agree that logical volume is created out of the volume group only, and there will be multiple logical volumes also created on the volume group, but the volume group name doesn't come from logical volume. It comes from the group of physical volumes because you can have more than one physical volumes combined together in the volume group. Now let us see in our system. First of all, we'll be running the command lsblk so that we can see what all the disks are there or what all the partitions are there on my system. I can see there is a disk called SDA and there is a SDB disk which we attached last time, and we also performed a cleanup. Now we have 10 GB of disk here. I will take both the examples. We'll create the physical volume out of a partition first and I'll show you how can we create physical volume using the whole disk. The command will be same, only the path will change. First of all, let's create a partition. N for new, P for primary, number 1. Let the first sector be empty. The last sector will create 5 GB of partition. Right? Yes. It says partition number 1 contains XFS signature. This is because we created the partition last time. Now we have erased that previous signature and we'll be writing these changes so that we can have a new partition of 5 GB. If this partition doesn't appear automatically, even though you have created the partition, you have to run the command part probe. Since it has already appeared, we don't need to do that. However, even if you do this, there is no harm, but this is not required here. If your partitions are not visible, you can run this command. Now, the commands of logical volume starts here. pv create and give the path of the partition or disk. Here we are using partition first, so HDB1. Enter. For the physical volumes, the path of the partition is the name of physical volume. But when you create a volume group, you have to specify a name here. Let's say this is the app server and we want to create a app VG. We are giving the name to our volume group. Now, whatever disk you are using here, You can use more than one disk also. Since we have only one, we are using only one. If we have more than one disk, we can define all those disk path parallelly together. Press enter. The app VG has created. To check the physical volumes, you have to run the command pvs, that stands for pv show. These are the two physical volumes on my system. Don't get confused with the disk partition and physical volumes. Physical volumes are the component of logical volume manager that is made separately, that is intentionally made. We cannot say that SDA1 is also a partition, why it is not listed in physical volume. Physical volume is a component that we created manually. SDA3 was created during the OS installation automatically, but it was created as a physical volume, so it is getting listed here. VGS will list all your volume groups. We have app VG, we have Ubuntu VG. This VG was also created during the installation, and this is the one which we have created for 5 GB. Now we can create a logical volume out of it. So the size of logical volume can be maximum less than 5 GB. Now to create the logical volume, run the command lv create. Here give the name to the logical volume using option -n. uh, I'm using app lv. You can use any name, it's not a code, it's just a random name. If you want to give your name, you want to give server name underscore lv or -lv, even this underscore lv is also not a code. It is just to recognize, or it's a standard way to do it. If you want to give your own name also, there is no problem, it will work properly. Now give capital L to define the size. Here you can use small l also. Small l is for blocks and sectors definition, and capital L is for MB/GB size definition. Now I want to create a 4 GB partition out of it, or if I use small l and use 100% free, if I use this command, whatever space is left on your app VG will be taken by this logical volume /dev /app VG. Remember that VG goes inside the /dev again. Now you are not creating your logical volume on top of HDB1 actually. You are creating it on the top of app VG, which resides inside the /dev again. Press enter and your logical volume is created. Similar command lvs to see all the logical volumes. Now app lv has been created equal to the size of your app VG. Now if you see the VGS, there will be zero space left in your app VG. From here, all the steps are quite similar to your standard partitioning. As you have the partition, now next you do the formatting with mkfs.ext4 or xfs, whatever file system type you want, and then you give the path of the partition there. Here the partition path will be /dev /vg name /lv name. Press enter. The disk has been formatted. Next is you create a mount point called /app. It may exist because we created last time. Now we'll be mounting it. Mount /dev /app vg app lv on the /app. And if you run df-h, you can see the 5 GB file system /app has been created. And similar to the standard partition, if you want to make a permanent mounting or persistent mounting, you can use vi/etc/fstab. Remember the path here, you can use this path, or you can also use /dev /appvg/applv, or you can also use blkid of /dev /appvg/applv. This UUID copy this whole thing, and this path can also be used. This is the ID of your partition. This is the mapper path of your partition, and /dev appvg slash applv is the partition path or volume path. Any of these three things can be used into the fstab entry. Slash etc slash fstab, do vi on it, go to the last line, it's already there, press O to create a new line, then slash dev slash app underscore vg slash app underscore lv tab. Where is it mounted on? Slash app tab. What is the file system type? It's ext4 tab. The permissions, defaults, log dump and fsck. And to check whether we have done the correct entry, we can use mount-va. It says ignored or already mounted, so every entry is correct, there is no problem. Now if I restart my machine also, my partition will not be missing, it will get mounted automatically. Now if I want to extend my file system, let's say that application team says this 4.9 GB is almost used and we want to have 5 GB space extra. Now, first of all, you will be checking whether you have the space left on your VG or not. You can see the V free is showing 0. Now you will have to extend your volume group. How will you extend it? By adding a new physical volume to it. And we do not have any physical volume that is unused. So we will be creating a new physical volume. Again, now we have two options. We can create a new partition into the SDB because we have still 5 GB left here. We can create a partition here, or to show you how do we use a whole disk, now I'll be shutting down my server and I'll attach a new disk on my virtual machine and then I will create the physical volume out of a disk. Shutting it down. Just a reminder that this is only in Oracle VirtualBox that we need to shut down our system in order to attach a new disk. Into the real-time environment, you don't have to power off your server. The disk attachment will be done live. Once the system is powered off, go to the settings, click on storage, click on the add hard disk, click on create, next. Here I'm taking 12 GB to create a new disk, and the one which is not attached, you have to choose that. You can see the third disk has been attached. Click on OK and power on your machine. Once the server is powered on, restart the session and switch to root. Now if I run the lsblk command, see the output, another disk of 12 GB has been attached. Now you don't have to create a partition, just run pvcreate /dev /hdc. This time the whole disk will be made as a physical volume. Always remember that the LVM which you want to extend can be extended only if there is a space in its own volume group. So you have to extend that volume group if there is no space left by creating another physical volume and extending your volume group using the new physical volume. VG extend app underscore VG, give the path of the physical volume. Now if you run VGS, you can see 12 GB has been added to the app VG. Now I can easily extend my logical volume app LV by 5 GB. How do you do that? LV extend hyphen capital L. This time you don't have to give the name because you have already created the logical volume. Remember this, I have seen many people repeating the same mistake again and again, that they use hyphen N while doing the extend plus 5G. This time I'm showing you the use of capital L. Last time we saw how do we use small l with 100% free. I'm defining the size here, and this time you have to give the path of logical volume. Press enter. If you see lsblk output, now your app LV shows as 10 GB. However, if you run df-h, the file system /app is still showing 5 GB. The reason behind that is we did not resize the file system, we just extended the volume. To resize the file system, we have two commands. If the file system is ext4, we have to use resize to fs, and if the file system type is xfs, we have to run the command xfs underscore growfs. So our file system is of ext4 type, so we'll run command resize to numerical to fs slash dev slash appvg applv. If it was xfs file system, just to show the command, don't get confused. If it was an xfs file system, then we would be using this command xfs underscore growfs. But this is a ext4 file system, so we'll be using resize to fs. Now if you see df-h output, the slash app shows 9.8 GB now. This is how we can extend our logical volume. I'm not showing you how do you reduce it, but if you want, you can run lv reduce -l slash dev slash appvg slash applv. This is the command to reduce the file system, and this command can be executed only in the ext4 file system types. XFS file systems cannot be reduced, it can be only extended. Nowadays, file reduction is not in practice. We do not reduce any type of file system, be it ext4 or XFS. Even though we have the feasibility in ext4, but we do not use it because there is the chance of file system corruption, and also you need to unmount the file system to do the reduction. This is the command. You can have it for information, but I'm not going to execute it. So we have understood that we can create the physical volume out of a partition or out of a disk, and then we can combine multiple physical volumes in a volume group, and then we can create the logical volume out of the volume group. And after creating the logical volume, the same steps are performed, such as formatting the partition, then mounting it on a new mount point, and also if you want, you can give the permissions or the ownership to the directory for the particular user. Next is how do we clean up this. So first things first, remove the entry from fs tab. Go to the last line by pressing shift G and press double D to delete this line. You can also comment it if you are going to use that file system later or mount that file system later. Do not delete the entry but comment it. Since I am going to clean it up completely, I am not commenting it out. Press W Q bang, save the entries. Now unmount the slash app, and now we will be deleting the lv remove slash dev slash appvg applv. It is asking for the confirmation, say yes. Now vg remove slash dev slash appvg. You can also use appvg, it will understand. Now pv remove, we used two new pvs, that is slash dev slash hdb1 and slash dev slash hdc. Both are wiped. Now if you run lsblk, hdc is completely free. However, the partition which we created is still there. So if you want to clean that also, use fdisk slash dev slash hdb. Now press D to delete the partition, press W to save it. Run lsblk again. The whole tree is clean. Now these two disks can be detached from the system and your volume will be reclaimed. Hope you have understood what is logical volume and what is the use of it, how it is better than standard partitioning, how do you create and how do you extend the logical volumes, what all the components are there and how can they extend or how can they reduce, and all the commands which can be used to manage the logical volume manager. If you have any questions or if I have missed anything you think, please comment down, and if you liked today's class, please like this video and subscribe our channel for more. we will be completing the Linux classes soon, and then later on we'll be starting the cloud classes. So stay tuned with us. Thank you so much.